Hello, good morning viewers. In this tutorial, we are going to derive the general formula used to find the end term of an arithmetic progression sequence. So far, we have seen that each time you add a constant common difference to a term, you shall obtain the subsequent term. Therefore, we can apply that idea to find the end term of an arithmetic progression sequence. So let me first of all arrange my sequence. So first, the first term is T1, second term is T2, T3, T4, let me stop here, up to Tn. First term is donated by A as always, and you know that every time you add a constant common difference, you shall obtain subsequent term. Therefore, to obtain the second term, we can add the constant common difference to the first term to obtain the second term. Therefore, second term will be first term plus common difference, which is going to be A plus D. To get the third term, we are going to add the constant common difference to the second term. And the second term is A plus D, plus another D will make it A plus 2D. For the fourth term, we are going to add constant common difference to the third term. A plus 2D plus another D will make it A plus 3D. So if this is true, how can we get Tn, that is the nth term? Let us observe something here. In all of these terms, the number of D is 1 less than the number of term. What do I mean here? Let's start from term number 4. You can see the number of D here are 3, but the number of term is 4 and 3 is 1 less than 4. The same thing goes to term number 3. You can see the number of D, which is the constant common difference, is 1 less than the number of term because that is term number 3, but the number of D is 2, which is 1 less than that. The same thing here. You can see we have a single D here, but term number is 2. So 1 is 1 less than 2. But you can see here we don't even have a D, which means that it is 0. 0 is 1 less than 1. And in each term, A is added to the number of common difference in the term. So therefore, we can use this idea to find n term. N term will be A as always because each term contains A plus the number of common difference will be 1 less than the number of term. The number of term here is n, so we're going to have n minus 1d. Therefore, we can conclude by saying that every term, let me say nth term, can be obtained by adding a to n minus 1 number of common difference. Let us see whether this statement is true. For instance, suppose we have a sequence like 2, 4, 6, 8, and 10. This is a linear sequence because you can see it has a constant common difference of 2. Every time you subtract subsequent term from the previous term, you're going to obtain 2. So from this sequence, you can see that the constant common difference is 2. And the first term, which is denoted by A, is also equal to 2. So what if we want to find this term, which is term number 4? Let us see whether this formula is applicable. So to find term number 4, where n is equal to 4, let us substitute this information into this formula to see whether we are going to find this 8. T4 is now equal to A, which is the first term, is 2 plus n number of term is 4 minus 1, then multiply by the constant common difference, which is 2. This is equal to 2 plus 4 minus 1 is equal to 3. So we have 3 multiplied by 2. Then we have to start multiplication before addition. This is 2 plus 6. And 2 plus 6 is equal to 8. And hence this formula is applicable. Sometimes our n, which is the number of term, can be relatively larger. In that case, we don't have to be using common difference each time. We can just apply our formula direct to find that term. So first we want to find the 100th term of this sequence. You know, it is not normal to be adding constant common difference 100 times just to get the 100th term. We can just substitute everything in this formula to get that 100th term. So let me do it here. When n is equal to 100, let's substitute to find out what is the 100th term. T100 is now equal to a, which is 2, plus n, which is 100, minus 1 multiplied by the constant common difference 2. This is going to be 2 plus 99 multiplied by 2. 99 multiplied by 2 is equal to 198. So this becomes 2 plus 198, and this is equal to 200. Remember that our sequence has a constant common difference of 2. Therefore, 2 times 100 is going to be 200. And hence, this formula is true for all arithmetic progression sequence. And this is all I have for you today. Thank you for watching. Do have a nice day.